In this video, we're going to install two important packages. One is TorchSDE and the second is TorchAudio. If you remember in the previous video, when we ran ComfyUI, we got some errors saying that ComfyUI could not find a module named TorchAudio. In this video, we'll fix that. Once again, there were several issues while I was going through this installation process, and I've cleared all of that up for you, and you should be able to install it as easy as 1, 2, 3. There are quite a few steps, so let's get started without further ado. First, we'll install TorchSDE. That is very simple, so let's just get that done and out of the way. To install TorchSDE, all you've got to do is pip3 install TorchSDE and hit enter. I already had it installed, but you can see here that the requirement for TorchSDE is already satisfied on my system. For you, this will go ahead and install just fine. You shouldn't have any problems with it. If you do face an issue, put it in the comment. I'll take a look at it and I'll help you out. Now let's clear our screen and get ready for the big one, which is TorchAudio. Just like we did for TorchVision, we need to compile TorchAudio from source. This is because we need TorchAudio version 2.5.0, which aligns with our PyTorch version. If you want to confirm your PyTorch version, do Python 3, and in the Python prompt, you can import torch and then print torch.__version__. And there you would see the version. We have 2.5.0 as our torch version. So we need to align with this version for TorchAudio as well. Now, it would have been super easy if there was a Python wheel for 2.5.0 version of TorchAudio. Unfortunately, I could not find one, so let's do this and compile it from source. Compiling TorchAudio from source is super memory intensive. I ran into several scenarios where the Jetson Orin would freeze during compilation and it would reboot itself back to the home screen without actually completing the installation. So we've got to take some steps here to give the processor more headroom as well as give it more swap space. Swap space is like virtual RAM. It is essentially just disk space, but when the physical RAM gets close to capacity, it will use the disk space that you've assigned as swap space as virtual RAM. So it kind of acts like supportive RAM while the physical RAM is getting close to capacity. Alright, enough theory, so let's just go ahead and get to the steps here. The first thing we'll do to give the processor more headroom is take us out of the graphical user interface that we have here with Ubuntu, and we'll go into full-on terminal prompt mode. To do that, you can enter the command sudo init3. So now we're in headless mode where we don't have a graphical user interface at all, we only have the command prompt. So enter your login information for your account. Once you're inside, make sure to source your Python virtual environment if you have one. And now we'll install some dependencies that we need. The first set of dependencies are going to be through pip install. So let's get that command going. So we need wheel, we need setup tools, we need CMake, and we need Ninja. Since I have all of those installed, it just says requirement already satisfied without doing anything. But if your system was lacking some packages, it would install those. Next, we'll install the dependencies that are needed through sudo apt. So let's do sudo apt install. We need FFmpeg. We need libavformat-dev. We need libavcodec-dev. We need libavutil-dev. libavdevice-dev. libavfilter-dev, and finally libsndfile1-dev. Enter your password to give it root access. Great. Since I have all of these installed again, it says 0 upgraded and 0 newly installed. For you, you'd likely have some of these packages get installed, and you shouldn't have any issues with this. Now let's check how much disk space we have on our system. So I have 171 gigabytes available. So as long as you have more than, let's say, 50 gigabytes, you should be fine. because we're going to assign 8 of those gigabytes as swap space like we discussed earlier. So to allocate the 8 GB as swap space, enter the command sudo fallocate -l 8 capital G for 8 GB. And then we want to assign this to a new location. I'm just going to call it /swap file. Let's give the swap file read and write permissions for the root user. To do that, we do the chmod command with 600. So that's read and write for the root and no permissions for the other user groups. And we want to do /swap file. Now that we've allocated the swap space and given the right permissions, let's declare this as a swap space. We will use the command make swap, that's mk_swap, and give it the directory /swap file. Alright, now the last thing to do is to turn on the swap space using sudo swap on and then /swap file. So we now have the swap space allocated, defined, and active. Now let's go to your workspace or wherever you like to clone repositories. Now let's clone the TorchAudio repository. To do that, you can enter the command git clone https github.com/pytorch/audio. And I like to name it as a separate folder instead of just audio. I like the name TorchAudio, so I'm going to go with that. I have already done this clone, so I'm not going to do it again, but you should do it if you don't have the TorchAudio repository already. Since I have the TorchAudio repository already, I'm just going to cd into it. Once you have cloned it, cd into it as well. An important thing that we need to do is to make sure that our versions are aligned with the PyTorch version. So we checked previously that the PyTorch version was 2.5.0. So let's check out to the v2.5.0 branch in TorchAudio. We can now check that we're in the correct branch by doing git branch, and we see that we're detached at v2.5.0. Perfect. Now, here's another problem that I needed to solve when I was going through the installation myself. There is a file called ctc prefix decoder kernel v2.cu. This is a CUDA file, and it is missing a #include statement, which causes a compilation error if you just go through and compile it right now. Before we get into that file, I'm going to clear the screen so it's a little bit cleaner. Now let's navigate to that file and add the #include statement so that it doesn't error out during compilation. You can use any of the headless text editors like VI or Vim or Nano to edit this file. I'm going to use VI, and we want to navigate to source libTorchAudio cuctc source again, and this is where that file exists. So it's called ctc prefix decoder kernel v2.cu. Now the #include statement that's missing is cfloat. So let's include that right after the algorithm include. So #include cfloat. And that's the only change that we need. Now let's save and quit. Great. We're now back at the terminal. I'm going to clear the screen once again, just so it's cleaner. Another thing that we want to do to give the system a bit more headroom is to set the max jobs environment variable to 1. You can do that with the command export max_jobs, all caps by the way, equals 1. And now we are ready to start the compilation. So what you want to do is use _CUDA equals 1, and then you can do pip install -v dot and then -- no build isolation, and you can hit enter. Alright, so we're done. Now on your end, you would see a lot more steps. It completed much faster for me because I had already installed it previously and did not clear the build files. When I originally compiled it, it took me around 15 to 20 minutes, similar to TorchVision. So give it the time, unless it errors out, which it shouldn't because I've given you all the steps that you need here to get a successful compilation. So now's the moment of truth. Let's enter the Python 3 prompt. Let's import Torch first to make sure that nothing changed with Torch. We can print the torch.__version to make sure nothing changed there. Great, we still have 2.5.0. We can also check that CUDA support is available for Torch using torch.cuda.is_available. Great, that says true. Now let's import TorchVision and make sure that that's still good. Alright, that's a success. And finally, let's import TorchAudio as well. Alright, that is also a success. Woohoo! I think we've done it. Now let's go ahead and launch ComfyUI and check that we don't see those no module named TorchAudio errors that we saw in our last video. Let's get out of the Python prompt using the exit command. Now that we're back, you'll notice that we're still in the headless mode, so we want to go back to the GUI mode. To do that, you can do sudo init 5. Alright, we see our login screen, so go ahead and enter your credentials and get in. Let's open up a terminal. Since this is a new terminal, I'm going to go ahead and source my Python virtual environment. Now navigate to your ComfyUI directory, and here we can start ComfyUI using the Python 3 main.py --listen and --force flags. Alright, we're launching. Now we should not see the TorchAudio missing errors. And yes, there we go. We see the URL being posted, so we're ready to launch the ComfyUI web client. And if you scroll up all the way to where we launched ComfyUI, we see that there are no TorchAudio missing errors. This is great. So we have a clean synchronized stack of PyTorch, TorchVision and Torchaudio. ComfyUI should be really comfy now, pun intended, and it should play well with all your image generation tasks. Let's go ahead and test out generating an image just so we know that nothing is broken after the Torchaudio installation. I'm going to keep with the theme and I'm going to change the donut to a croissant, and instead of Paris, France, I'm going to say that they are placed on a marble table. Let's see how well this works. Click generate. We're just waiting for the model to load at this point. I hear the GPU working. Alright, so we have the croissant on a plate. We have something that looks like a coffee mug on the side, but you could always run it again and get a different image. For the purposes of this video, I think we can call it a grand success. We've installed TorchSDE, we've installed Torchaudio, in fact compiled it from scratch on a memory limited Jetson Orin Nano, and we were able to run the ComfyUI end to end and check that image generation works fine and you don't have any errors along the way. In the next video, we'll go through in a bit more detail about the sampler and look at all the settings that it has and see how changing a setting here impacts the output image. We'll also get some tidbits on how the algorithm works behind the scenes. But that's for another day. Great job on getting all the installation done. I'll see you in the next one.